Hey everyone, today we'll be learning how to add and subtract fractions with like denominators within word problems. We'll also be learning how to subtract a mixed number from a whole number. For guided learning part A, Jefferson and Dylan bring in Takis to share after school. Jefferson's bag of Takis is 1/4 full. Dylan's bag of Takis is 2/4 full. If the boys combine their Takis, what fraction of a bag would be full? Use a visual to help you. So as I'm reading it, I'm realizing that we're combining both Jefferson and Dylan's Taki bags. Combine means that we're going to be adding. So we're adding 2/4 and 1/4. So I'm going to change the color. Let's see, we'll do blue. Let's represent 2/4. We have 4 parts, and we're going to shade 2 of them. And then in this next one, we're going to be adding 1/4, 4 equal parts, shade 1 of them. So in total, we have 1, 2, 3 parts shaded out of 4 parts in each hole. So 2/4 plus 1/4 equals 3/4. For part B, a new rag has 1 bag of M&Ms. He shares the bag with some friends after school. By the end of the day, only 1/3 of the bag is left. What fraction of the bag of M&Ms were eaten throughout the day? Use visuals to help you solve. So I'm seeing that there's a new rag is starting with a full bag, so that's 1 bag, and they're eating the M&Ms throughout the day. So that means if we're eating, we're subtracting, we're taking away. And by the end of the day, there's only 1/3 left. Well, I know that 1 whole is equivalent to 3/3. And I can represent this by having a whole here. 1 whole can be split into 3 parts. We had all 3 of them shaded. So the entire thing is shaded. And now we're going to remove 1 of those 3 parts, leaving 2 parts left. So that would be 2 out of 3 parts. 3/3, or 1 whole, minus 1/3 is 2/3. So that means that throughout the day, a new rag and his friends ate a total of 2/3 of the bag. Part C. Aries runs at football practice. He ran for 2 3/6 miles on Saturday and 3 2/6 miles on Sunday. How far did Aries run over the weekend? Use visuals to help you solve. Well, I'm seeing that he ran a certain amount on Saturday and he ran more, another 3 2/6 on Sunday. So I know I'm going to be adding. Oops, let me change to eraser. So we're going to be adding 2 3/6 plus 3 2/6. So let's represent 2 3/6. We have 1, 2, and 3/6. We're going to split each of these into 6 parts. So here we have 2 parts completely shaded and 3 parts of the next one shaded. We're going to be adding 3 holes and 2 6 up another hole. So we got to break these into 6 as well. Each part is broken into 6. We're going to shade 3 holes and 2 6 of another hole. So let's see how many holes we have all together. I'm going to use a different color. We have 1, 2, 3, 4, 5 holes shaded all together, which makes sense because 2 plus 3 is 5. Now let's see how what fraction parts we have. So we have 3 parts here plus the 2 parts here. Well, that's 5 parts shaded out of 6 total parts, which makes sense because 3/6 plus 2/6 equals 5/6. So our answer is that Aries ran 5 5/6 miles over the weekend.
Samantha rode her bike for 1 3/5 miles on Saturday and some more on Sunday. If she rode her bike for a total of 3 4/5 miles over the weekend, how many miles did Samantha on Sunday? Use visuals to help you solve. So we know that over the weekend, she ran for a total of 3 4/5. So I have 1 whole broken into fifths, 2, 3, and I need another one so I can have 4/5. 1, 2, 3, 4. Okay, so we know that she ran a total of, let's see, change the color. 1 hole, 2 holes, 3 holes, and 1, 2, 3, 4/5. So we know on Saturday, she ran 1 3/5 miles. Now let's figure out how much she ran on Sunday. So we have her total miles over here is 3 4/5. So now what I'm going to do is I'm going to cross out 1 3/5, and then that will tell me how many miles she ran on Saturday. So I know that 1 hole is one of these. So I'm going to cross out one of these. So that's 1 hole, and then 1/5, 2/5, 3/5. So what I'm left with is 1 hole, 2 holes, and 1/5. So I'm left with 2 holes and 1/5. Now I'm going to show using a written method to align to my visual. So I have 3 4/5 minus 1 3/5. So the first thing I'm going to do is I'm going to subtract my fractional parts first. So 4/5 minus 3/5 is 1/5. And then I subtract my whole parts. 3 minus 1 is 2. So Samantha biked 2 1/5 miles on Sunday. All right, now going on to the next slide. Okay, Miss Spencer ran 1 2/5 miles on Saturday and some more on Sunday. If she ran a total of 3 miles over the weekend, how many miles did Miss Spencer run on Sunday? Okay, so this is similar to my last problem. So I'm going to draw, so we know that Miss Spencer ran a total of 3 miles. So we have 1, 2, 3, and we're broken into fifths. That's 1 mile. Okay. 2 miles. 3 miles. Okay. And we're broken into fifths because our denominator here is in fifths. So on Saturday, we know that Miss Spencer ran 1 mile, which is 5/5, and 2/5. So now, because this total represents 3 miles, our blank spots represent how many miles Miss Spencer ran on Sunday. So now we can count to figure out how many miles that is. So 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5. So she ran 8/5, okay? And I can convert this fraction greater than 1 into a mixed number because I know that 5/5 is 1 whole and 3/5 is left over. So I know that this equals 1 whole and 3/5. And I can also see here, I have 1 whole and 3/5. Okay, so now I'm going to use a visual, a written method to show how to solve this problem. So let's see. So I have 3 minus 1 and 2. I know I can rewrite 3 as 2 and 5/5 minus 1 and 2/5. I subtract my fractional parts first. So I have 5/5 minus 2/5 gives me 3/5. And 2 wholes minus 1 whole is 1 whole. So Miss Spencer ran 1 3/5 miles on Sunday. All right, now we're going to move on to the next one. Oh, that was the end.